So in the same way that there are equations, right? And what makes an equation, as opposed to like an expression or something? An equal sign, right? So it's called an equation because it has an equal sign. It's saying, it's saying that these two sides of, on each side of the equal sign are equal. Like it's sort of proposing a sort of relationship between the left side and the right side. Let's say has an equal sign. Okay. So it's called an equation because, it's literally saying that they're, two sides are equal. An inequality is very much like an equation, except instead of saying that two sides are equal, it's saying that the two sides are not equal in some way. Now, of course, there's only one way for two things to be equal, right? Which is why there's only one kind of equal sign. But there's a lot of ways for two things to be unequal. Maybe the left side is bigger than the right side, or maybe the left side is less than the right side. Maybe they're less than or equal to, or greater than or equal to. So there are 4 types of inequality symbols. And I will find the space to write them somewhere. Okay. So, let's see. This symbol means less than. And it specifically means that what's on the left of it is less than whatever ends up being on the right of it. The symbol that faces this way is greater than. And it specifically means that whatever is on the left side of this sign is greater than whatever is on the right side of this sign. There's also this symbol. It's basically a less than sign with a sort of horizontal bar below it. So it's kind of halfway between a less than and an equal sign. And that's because this is the less than or equal sign. And last, there's this sign. So the greater than symbol with a horizontal bar beneath. Because this is the greater than or equal to sign. So those are the 4 kinds of inequality symbols. Really, it's more like, it's not really like there are 4 kinds. It's more like there are 2 kinds with 2 variations each or something. Okay. So, knowing that these are what the symbols are called, how would you read this out loud? How would you read example 1 out loud? Yeah. So x is less than or equal to 7. So x is some number, right? We're sort of trying to figure out what it is. Just like for an equation, we try to figure out what x is. But boy, there are a lot of numbers that are less than or equal to 7. Can somebody name some numbers that are less than or equal to 7? 7 is less than or equal to 7 because it is exactly equal to 7. Okay, so let's see. So I guess x values at work. Seven. Okay. Are there any other numbers you can think of that? One. Okay. Sure. Any others? Okay. 2, 3, 4, 5, 6 as well, and also 0 and -1, -2, -3. I could do -3.1, -3.01, and I could just write numbers forever and never be done. So unlike an equation which has only one solution, these inequalities are going to have solutions that cover a range of values. And those ranges, and this is not the last time you're gonna hear about these, but those ranges of values are called intervals. And we're going to describe the set of all the numbers that work as an interval, as opposed to, a comma-separated list that goes on forever and never ends, just because we don't want to write lists of numbers that never end. You could literally do this forever, and you would still never be done. Okay. So we're going to figure out another way to write all the values that work, all the values that are less than or equal to 7. Okay. But the first thing we're going to do is we're going to make a graph. And it's not a big graph, it's a one-dimensional graph, it's a number line. So just write in a little horizontal little number line here. Okay. On the right-hand side, now the right-hand side of the number line means, you're going more positive. The left-hand side of the negative sign means you're going to go more negative. So on the right-hand side of this number line, draw in an infinity symbol. And on the left-hand side, draw in a negative infinity symbol. It just means that you can go that way forever, or, that other way forever. Okay. Now, really, the only number that's truly of interest here is 7. So just put a little tick mark in the middle and label that 7. Okay. And we're going to try to shade in all the values that are less than 7. So for example, if I were to write in some other values, on this side would be like 6, 5, 4, and if I had a bigger number line, I could go, 3, 2, 1, 0, -1. And on this side are going to be numbers like 8, 9, and 10. Now, I can either shade in the left side of this, the left side of the number 7, or the right side of the number 7. If I'm trying to get the numbers that are less than or equal to 7, which way should I shade starting at 7? Should I shade to right, because to the left is going to be the numbers that are less than 7. So I'll just shade that in. And right on the 7, right to sort of cap off this shaded area, I'm gonna put a little bracket, or some of you may have learned it as a closed circle, and that's fine too. So either a closed circle as opposed to like an open circle, or a square bracket. You can do whichever you'd like. I'm just gonna do a square bracket because I'm gonna need a square bracket later when I actually write the interval. Okay. Now it's Well, you guys haven't seen an interval yet. The way that intervals are written are they're written as either a set of parentheses, brackets, or a mix. And there's going to be two numbers in the interval. The number where the interval starts, a comma, and then the number where the interval ends. So for example, and this is, I know this is sort of getting off track, or at least I know we're in the middle of a problem here. Let's say we had an interval that started at 1 and ended at like 10 or something. So wanted to start at 1 and end at 10. And let's just say that for this example, I want to include 1 as well. And I want to include 10. So the way that that interval would be written, right, that's how it would be graphed, but the way that it would be written is a square bracket, 1, comma, 10. Starts at the number 1. The square bracket tells you that it includes 1 as well. And then the 10 tells you that the interval ends at 10. Then the bracket tells you it includes 10 as well. Those numbers are called the endpoints of the interval. Okay. There's a lot of practicing that's needed. Okay. So let's just, maybe we're not super familiar with it yet, but let's just try to write this interval. We're going to not talk about where this interval starts for a second. But where does this interval end? Right, it ends at 7. With a bracket because we're wanting to include 7. Now, as for where this interval starts, if you start at 7 and go to the left forever, there's not going to be there's not going to be a lowest number that you stop at. There's always going to be lower numbers. You could get to negative 1,000,000 over there on the left-hand side of this number line, and there would still be negative 1,000,001, or a negative a negative bazillion. There would still be like negative 2 bazillion, negative 3 bazillion. Or a negative Brazilian. So there's not going to be a number that you can say that it really starts at. So you're going to say that it starts at negative infinity. Yeah, and whenever negative infinity or infinity is one of your endpoints, it's always going to have a parentheses on it. And the reason for that is negative infinity isn't like a real number. You can't ever reach it. You can't touch it and grab it and say, hey, I've got negative infinity, in the same way that you can say hey, I've got the number 7. So negative infinity and infinity are always going to have parentheses associated with them because you can never truly include them, just because they're so, they're forever in that direction. You're never going to actually get to it. Okay, so that's the interval notation. You have an interval that starts at negative infinity and goes up to 7, then it includes 7. Any number within that interval is going to be a solution to the inequality. Any number in here, any number in between negative infinity and 7, including 7, is going to be a number that is less than or equal to 7. And this interval includes 6, it includes 5, 4, 3, 2, 1, 0, negative 1, negative 2, it includes negative 3, and negative 3.01, and negative 3.001. It includes all those numbers at once. It doesn't include 8, it doesn't include 7.5, it only includes numbers that are 7 or less. But that's how we write the great many numbers that are less than 7 that are out there.
have a question.
Yes.
Why is it parentheses? Is it because it's
The negative infinity? Yeah, negative infinity and positive infinity are always just going to have parentheses no matter what. It's like,
I got it. No, yeah.
Okay. Okay, I mean, you don't even have to get it. You can just remember negative infinity and infinity, always parentheses. Okay. So, what color can I use here? So these, the two symbols that read less than and greater than, and you might hear me say strictly less than or strictly greater than, to differentiate it from the other two. But these less than or greater than symbols are going to have parentheses. They're going to have inequalities that have these symbols are going to have intervals that like have parentheses on them. I'm sure you will find better places on your own paper to write this. I mean, I have to write big, like comparatively, so that you all can see it. You will have to come up with a different excuse. And these two symbols, the ones that are allowed to be equal, right, or the or equal to signs, those are going to have intervals that have brackets on them. And that bracket, as opposed to the parentheses, represents the fact that it's allowed to be exactly equal to whatever number it's being compared to. Right. So, I'm running out of time. Okay. We'll draw another number line here, and after we do a couple of these, I'll show you a trick for how, you can sort of skip sort of step of like interpreting some of these inequalities. Okay. So same way, start off the same way as before. Number line with negative infinity on the left and infinity on the right. In this inequality, x is greater than negative 6, your number of interest is negative 6. Now, as with all number lines, the numbers that are greater are going to be on the right, and the numbers that are less are going to be on the left. What is x compared to negative 6? What is the meaning of the symbol here? Greater than. So x is greater than negative 6. So that includes numbers like negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Those are all greater than negative 6. So which side of negative 6 are we actually going to want to shade?
The right.
The right. We want the numbers that are greater than negative 6. And we can just go on shading forever. So, the righter we go, the even bigger than negative 6 we are. So we just sort of shade to the right forever. So that we have this interval that starts at negative 6 and goes all the way up to infinity. Okay. Now, do I include negative 6? No, because I want numbers that are strictly greater than negative 6. I don't want them to be equal to negative 6. That's not good enough. I want them to be specifically greater than negative 6. So I don't want to include negative 6. But I do want my interval to start there. I just don't want to include the negative 6 itself. So I'm going to put a parentheses right there without covering up the very number I'm trying to... Yeah. Okay, cool. Okay, so we got an interval that starts at negative 6. So parentheses, negative 6, comma. Where does this interval end?
Infinity.
Infinity. And what kind of is it gonna have a bracket or parentheses on that
A
infinity?
bracket. Wait, why in parentheses?
Infinity will always have a parentheses. Negative infinity and infinity will always have a parentheses on them.
So why does it have a? Okay.
It has it because you
So
can't.
Why is that one in parentheses and the other one's in parentheses and a bracket?
That's got to do with the symbol that's right here.
Oh, I see.
Yeah. If it's less than or equal to or greater than or equal to, if it's these two symbols, those are going to have intervals that involve brackets. And that's because they're allowed to be equal to one of their endpoints. Whereas a symbol like this, without the horizontal bar, where you're just strictly less than or strictly greater than, those are going to have intervals that involve parentheses instead. And it doesn't even have to be a particularly big number line. The important thing is that it has negative infinity on the left and infinity on the right, and it has the sort of number of interest somewhere in the middle. So this inequality reads x is greater than or equal to 4. So if I say put the number 4 right here in the middle of this number line, and I want the numbers that are greater than or equal to 4, should I shade the right side or the left side of 4? Yeah, the right side, sort of just like the previous problem, really. I want to shade the right side. However, unlike the previous problem, x is greater than or equal to 4. So x can be equal to 4, meaning that I can end this interval at the 4 with what sort of symbol? A bracket. Okay. And that's it for the graph. The graph doesn't take a lot of doing. It doesn't have to be particularly wide. Yeah. So you got bracket. This interval starts at 4, comma, and where does this interval end? Positive infinity. So, yeah, positive infinity is always going to get a parentheses. Okay. Now, I guess it's time to. Actually, no. I'll wait on that. Okay. So we'll do this last sort of regular inequality example. Still a number line with negative infinity on the right. Sorry, negative infinity on the left and positive infinity on the right. And we're going to put down this number, -1. And the way that this is read, how is this relationship read, like verbally? X is less than -1. So I want numbers that are less than -1. Numbers like -2, -3. So what side of -1 should I shade in? The left-hand side. I want to start at -1 and shade in towards the left. And am I going to put a parentheses on that -1 or a bracket? Am I going to include -1 or not? According to the inequality, is it allowed to be equal to -1?
No.
No. So I want a parentheses on that -1. Okay, that doesn't even look like a -1 anymore. Okay. Sure. Okay, so there's our interval. Where does this interval start, so to speak?
-1, right?
It ends at -1. Yeah, what's
So it starts at infinity then, right?
it starts at negative infinity. Because it's over on the left.
So that's going to have a parentheses. So parentheses negative infinity. And it goes up to -1. And -1 also has a parentheses on it.
Okay, so in the past, you may or may not have heard, may or may not have heard about like mnemonics for how to interpret the inequality symbols. Some people say that the inequality symbol is like an alligator in between two quantities, and the way that it opens to is the bigger thing. But we're not really going to talk about that yet, or possibly even at all. What I do want you to notice is look at the way that this sign is pointing. Like, if you think of it as a sort of arrowhead that's pointing either left or right, which way is that sort of arrow pointing? Yeah, it's sort of pointing to the left. And which side of our number did we shade on the number line? The left. Okay. Let's look at this one. If we think of this as an arrowhead, sort of like sort of like that, which way is it pointing? Right. To the right. And which side of our number, -6, did we shade? Right. To the right. And is the same true of this inequality and this inequality? This is, for example, 3, it's pointing to the right, and we shade it to the right. In example 4, it's pointing to the left, and we shade it to the left. So that's something that's just always going to be true. On the condition that x is on the left. X has to be on the left in order for you to interpret the inequality symbol this way. And the reason for that is I could take an inequality like x is less than or equal to 7 and rewrite it with the exact same meaning if I say 7 is greater than or equal to x. And so, that's got the exact same meaning. Yet because, the two sides are flipped, the inequality symbol is also flipped. And that sort of relationship between which way the inequality symbol is like pointing and which side of the number I'm shading kind of breaks down if I allow this sort of thing to happen. So it's just write somewhere that it is highly recommended to keep x on the left when you're dealing with inequalities. It's not a crime if your x ends up on the right, but it is going to make things harder to think about. Because, let's just say, let's say we have an inequality like that, 3 is greater than x. That's already pretty weird to think about. So 3 is greater than x. So x is all the numbers that 3 is greater than. It's much easier to flip this around and say x is less than 3, right? X is all the numbers that are less than 3. It means the same thing as x is all the numbers that 3 is greater than, but x is less than 3 is so much easier to think about. So that's sort of like why it's recommended to keep x on the left, because x is what you're interested in. X is what you want to compare other things to. You don't want to compare. You don't want to compare them the other way around. So just try to keep x on the left if you can. If you can't and you end up with something like this, just flip both sides and also flip the direction of the inequality to get like an equivalent inequality that's like easier to read. Okay. Yeah, those will go quick. Yeah. Okay. So example 5 and 6 are a little special. They are what is known as compound inequalities, and they're called compound inequalities because this sort of thing is happening where you got not just x, a symbol, and then a number, but actually you've got like x in the middle of like two other numbers, and there are also two inequality symbols. However, these are kind of easier than regular inequalities. Even if they might look like they're going to be more difficult at first, they're actually easier. So, -4 is less than x, and x is less than or equal to 3. In other words, x is in between -4 and 3. So let's start with our number line. Negative infinity on the left, infinity on the right. There are two numbers here. -4 and 3. And make sure you write it like this. Don't write like definitely do not write don't write this. That is not the way the numbers are ordered. -4 should be to the left of 3 on a number line. Just because on a number line, left is lower, right is greater. Okay. So x is in between -4 and 3. So x is any number in between -4 and 3. Now, does this -4 have a bracket or a parentheses? Right, because of its symbol is strictly less than. It's going to have a parentheses. What about the 3? Is that going to have a bracket or parentheses? It's going to have a bracket because it's allowed to be equal to 3. And there it is. The interval is going to be -4 with the parentheses up to 3 with a bracket. Any number in that range is going to be a number that satisfies this compound inequality. And then this last example of a compound inequality, we're going to have the number 3 and we're going to have the number 8. X is any number that's in between these. So just shade the space in between 3 and 8. Is the endpoint of the interval at 3, is that going to have a bracket or parentheses? A bracket, right, because of this symbol that's going on here. What about the endpoint that's at 8? It's going to have a parentheses. So that interval is going to be read, or it's going to start at 3 with a bracket, meaning that it includes 3, and it's going to go up to 8, but with the parentheses, meaning that it doesn't include 8 itself. It just goes right up to 8 and then stops. Okay, so that's sort of like how to, interpret inequalities. Maybe if we have time to compare equations and inequalities, but The inequalities work a lot of ways in a lot of ways the same as equations, but there are differences too. Equations have a single number as a solution, whereas these inequalities, these intervals are the solutions to these inequalities. These intervals contain many numbers. But the point is that the solution to an inequality is not really ever just a single number. It's a range of numbers. Maybe a limited range of numbers, sure, but it is still a range of numbers. It's more than just like one number as your answer. Okay. Now we're gonna solve inequalities, right? In those examples up there, x was just like by itself on the left, so it didn't really take much to interpret them. Here it's mixed up with numbers being added, multiplied, not really that mixed up, but yeah. But we're going to deal with this very much the same as we would an equation. Treat this symbol in the middle the same way that you would treat an equal sign. Whatever you do to the left-hand side, you must also do to the right-hand side. And you're also going to try to get x by itself. What side is it better to have x on for these inequalities? The left-hand side or the right-hand side? Left. Okay. Luckily, our x's are on the left-hand side in this one. But I want to isolate that x. So what's the first thing I should try to get rid of? Right, that minus 3. We'll add 3 to both sides of the inequality symbol. And we'll end up with 4x, inequality symbol still like this. So 4x is greater than negative 20. And then we'll divide by 4. So x is greater than, what is negative 20 divided by 4? Negative 5. And so it becomes this simpler, but it still means the same thing, but it's just like written in a simpler way. X is greater than negative 5. So if you know what the interval is going to look like right away, I guess you can just write the interval. I'm still going to draw a number line. I'm going to put negative 5 on my number line, and x is greater than negative 5. So what side of negative 5 should I be shading? The right, the side that's greater than negative 5. You can also look at the way that this, since x is on the left, thankfully, we can look at the way that this inequality symbol is pointing to the right to know that as well. Now, this interval that starts at negative 5 and goes up to infinity, is it going to end with a parentheses or a bracket? A parentheses. So that interval is just parentheses, starts at negative 5, goes up to, what does it go up to? Infinity. And should infinity have a bracket? No. Yeah. A parentheses. We all have our, we all have our times. Now, as attractive as a prospect of subtracting 3x from both sides might be, and don't actually write this, because 7x minus 3x, that's really nice.
we can have something like this, and we won't have to deal with any negative numbers or anything. It's just going to make it harder to interpret. So because we want to keep our x's on the left, I'm actually going to start off by moving that 7x. I'm going to start off by subtracting 7x on both sides. And this is actually going to also teach us an important thing about inequalities. So that's going to be negative 4x plus 1 is greater than negative 15. Okay. And of course, if I want my x's on the left, that must mean I must want all my constants on the right. So I'll subtract 1. So negative 4x is greater than negative 16. What's my last step? Yeah, divide by negative 4. Okay. It does, yeah.
I remember that.
It's good.
4th grade.
Yeah. So x, okay, this side is positive 4. And because you divided by, not just because there's a negative number involved, I mean, technically there was a negative number involved in the last one and we didn't flip the sign, but because you divided by a negative number, and it also happens to be multiplied by a negative number, but because you use a negative number in an operation, this sign changes direction.
Wait. What?
Okay. Maybe this will help, and maybe it won't because I'm just thinking of it now. So 1 is greater than 2. No, what am I saying? 1 is less than 2. 1 is less than 2, right? Okay. Tell me that 1 is less than 2.
Yes.
Okay.
Mr. K, 1 is less than 2.
Okay. Now, imagine that I multiplied both sides of this by negative 1.
Okay.
Okay. This side would become negative 1, right? And this side would become negative 2.
Okay.
Okay. How do negative 1 and negative 2 compare? Is negative 2 greater than or less than negative 2?
Negative 2 is less than negative 1.
Right. So that means negative 1 is greater.
Correct.
Okay. We have to do that whenever we multiply or divide by a negative number because, like, making numbers and stuff, like the negative versions of themselves, flip the sort of relative positions of them. You know, like, whereas 1 and 2 have, like, this sort of relationship, you know, 1 is here, 2 is here. Negative 1 and negative 2 have, like, the opposite relationship. You know, negative 1 is here, negative 2 is here. Yeah. So that's just whenever you use a negative number as part of an operation. Okay, so 4 on our number line. We're going to shade to the left because we want numbers that are less than 4, x is less than 4. And again, you can just look at the direction that this is pointing because we have, you know, we made it so that x is on the left. So you can interpret the direction of the sign this way. Well, that's going to be the interval negative infinity, and negative infinity, you know, infinities always have parentheses on them. And it's going to go up to 4, and is that 4 going to have a parentheses? Right, it's going to have parentheses because of this symbol, right? It's not, it's not less than or equal to, right? It's just strictly less than. So that has a parentheses, that 4 has parentheses. Okay. This looks like it's got some fractions in it. Thankfully, it's not rational. It just has like numerical, you know, denominators here. But we'll deal with it the same way as if it were an equation. which is to say we'll find the least common denominator and multiply everything by the least common denominator. What is the least common denominator between 2, 3, and 6? It is 6. 6 is the lowest number that it's going to fit 2 in it, 3 into it, and 6 into it also. You could use other numbers like 12 or 18 or 24, but 6 is the least one. It's the least common denominator, 6. We're going to multiply everything by 6. X minus 4 over 2. I guess we'll just multiply that by 6. Is greater than, we're going to take 6 and multiply it onto this, x minus 2 over 3. And if you want, you can do 6 over 1. Doesn't, it's the same. Plus 6 over 6 over 1 times 5/6. Okay. Instead of multiplying them outright, what I would actually recommend is see if you can't sort of look at these and simplify them, the way they are right now. If you have 6 on the top and 2 on the bottom, what number is that going to be? 3. So that's going to be 3 times x minus 4. Right, the 6 on top and the 2 on the bottom, the 6 over 2 is going to simplify to being 3. It's greater than, what if you have 6 on the top and 3 on the bottom? What number does that simplify to? 6 over 3. Yeah, so 2. Times x minus 2. And, that's not the only way to do this. You can, go ahead and multiply this and then actually divide it by 2 and by 3 and by 6 later. Plus,
5, right?
Yeah, the 6's are going to cancel out. I mean, you can say that they're 1, but you can also just say that they cancel out, and it becomes plus 5. Okay, no more denominators. So distribute that 3. Distribute that 2. You can get 3x minus 12 is greater than or equal to 2x minus 4 plus 5. You can definitely combine these to be plus 1. Negative 4 and the 5. And now I have a variable on both sides, a constant on both sides. I want my variables on the left, preferably. So I'm going to subtract 2x from both sides. 3x minus 2x, that's going to give me x. So right now I have x minus 12 is greater than or equal to 1. I'm now going to add 12 to both sides. And that's going to give me x is greater than or equal to 13. All right, so just, go ahead and shrink your own writing.
I just drew a number line.
Okay. 13 goes on the number line. X is greater than 13. What side of 13 are you going to shade? Yeah, you're going to start at 13 and shade to the right, because you're trying to capture the numbers that are greater than 13. And is that shaded part, is that going to end in a bracket on the 13 or a parentheses on the 13? Let's see. Right. If you look at that symbol, that tiny symbol there, it's got that horizontal bar on the bottom.
Oh.
So it can be equal to 13. Which is going to give this a bracket on the 13. So how's this interval going to be read? Like if we write it as an interval with the numbers and everything.
So it would be 13, comma big?
Yeah, but what sort of symbol? So, right, a bracket on the 13 and parentheses on the infinity, because infinities always get parentheses on them. Okay, so here we go. Here we are. Okay. Okay. The remaining ones actually aren't that bad. Certainly they won't cause us to rewrite every term and try to multiply it by some least common denominator. Okay, so just simplify. Take this -3, distribute it into the parentheses. That's pretty much the only step we're really going to have to do before we start, dealing with this. So -3 times x is -3x. -3 times +2. Right. So we got -3 minus 6 on the left-hand side of this greater than symbol. Right side of this greater than symbol is just 2x minus 11. Okay. Now, while my x is on the left, so as tempting as it might be to add 3x to both sides, I'm actually going to subtract 2x instead, so that I get to keep my x's on the left. That's going to give me -5x minus 6 is greater than -11. I'm then going to add 6 to both sides. Okay, so -5x is on the left. There's a greater than symbol. What's -11 plus 6? -5. Okay. What is my last step to find out how x relates to,
Divide by -5.
Okay.
But
Right, we are dividing, so now we're dividing by -5. We're dividing by a negative number. Yeah, we gotta take, because of the, yeah, that's too wide, okay. Because of this, we gotta take this and flip it. So x is actually less than what we get from this, which is 1. And so number line wise, -infinity, infinity is here, 1 is here. I'm just gonna write it like this. X is less than 1. What side of 1 should we?
to the left side.
Yeah, we're gonna start at 1 and shade to the left. And is there gonna be a bracket or parentheses on the 1?
I'm never gonna get this right.
Just think of like, a bracket's going to be when there's that sort of very straight horizontal bar on the symbol. And brackets are very, they're very straight, they're very rectilinear, whereas parentheses are not. So I guess just keep that association in mind, like when there's that horizontal bar, that's when you use brackets. Yeah. But there's not in this case, so we'll use a parentheses. So where does this interval start? Like what's the leftmost part of this interval? -infinity. Okay, and it goes up to 1. Parentheses on both. On the -infinity because it's -infinity, and on 1 because, well, that's what it was because of the symbol in the inequality. Okay. The least common denominator in this one, and there is going to be one because there is a fraction, is just 2. So we'll just multiply everything by 2. And in fact, that's such a small least common denominator that I'm just going to do this. Actually, that makes it look like I'm squaring it. I'm going to write it here. Okay, and okay. So that's going to be 2 times 1, so that's 2. The 2 is going to cancel out on the middle term, so that'll just be minus x is greater than 2 times 4, so 8. My x's, I guess, are on the left, so I'll subtract 2 on both sides. -x is greater than 6. Okay. Am I done? No. What do I have to do? Divide by -1. If you just have a negative sign on your variable and you're trying to get the variable by itself, just divide by -1. That'll give you x. That'll also give you -6. But what symbol will be in the middle? Yeah, instead of a greater than like it used to be, it's going to flip around, it's going to be a less than symbol, because we divided by a negative number. I don't know why it looks the way it does. Okay. We'll skip example 6. You would just add 2x to both sides and then subtract 24 to get your x's over on the left. Probably the best way to do that. Okay. Now we're going to deal with compound inequalities. Just like example 5 and 6 up there. This will not take long. I promise. Okay. So whereas with regular inequalities and with equations, we have like two sides to deal with. With these compound inequalities, with the two inequality symbols, it's kind of like there are three sides to deal with. A left side, a right side, but also like a middle. And you're trying to isolate the x in that middle. But it still holds true that whatever you do to one side, you must do to, I guess instead of saying like the other side, you would say now, the other sides. Whatever you do to the middle, you must do to the other sides. So if I'm trying to isolate x as I normally do, what's the first thing I should try to do? Subtract 3. I'm also going to do that on the right and on the left. So I'm subtracting 3 in 3 places. 1 minus 3 is -2, less than or equal to. Now the middle is just 2x, less than. 11 minus 3 is 8. The only one thing left to do to isolate the x, what is that? Divide by 2. And I'm going to do that on the left-hand side and the right-hand sides as well. So -1 is less than or equal to x is less than 4. Or in other words, x is in between -1 and 4. And these are the ones where, it's pretty easy to write down what the interval is. You don't even really need a number line for this one, even if you need one for the inequalities up there. It's just the space in between these two numbers. Okay, is -1 going to have a bracket or a parentheses on it based on this symbol? A bracket. What about the 4 based on this symbol? A parentheses. So bracket -1, comma, 4 with the parentheses. Easy peasy. We'll try to knock out another one, I guess. Example 2 is going to be much like example 1, so we're not going to do it. All you would do is add 1 to all 3 sides and then divide all 3 sides by the number 2. Example 3, I guess you can multiply everything by 3 to begin with, but I'm not going to do that. I'm going to actually add 5 to all 3 sides. Okay, so -3 plus 5, that left-hand side is going to be 2. It's less than or equal to. The middle is now simply x over 3, and it's less than or equal to, well, -1 plus 5 is 4. And now comes the time to multiply by 3, if I do things in this order. So I'm just going to multiply everything by 3. So what number do I have on the left?
So 6 is less than or equal to x,
Mm-hmm.
which is less than or equal to 12.
Yeah. So x is in between 6 and 12. And I'm not even going to do a number line for this. What two numbers are going to be the endpoints of my interval? 6 and 12. So 6 comma 12. And brackets on both because of these symbols right here.
Okay, I'm gonna get this.
Yeah. Inequalities are easy. Last one real quick because it involves a negative coefficient. Subtract 6, you can, that part's easy enough. Subtract 6 from all sides. Negative 16 is greater than negative 2x is greater than negative 26? Yeah. Divide by negative 2. And what must you do when you divide by a negative number? Flip the signs. There are 2 signs. Flip each of them. Left-hand number is positive 8, and the right-hand number is 13. So x is in between 8 and 13.
So it'll be parentheses 8, comma, parentheses, or 13 parentheses.
But yeah. So these compound inequalities are actually easier than the other ones. Yeah, because they have 2 numbers as their endpoints as opposed to like infinity or negative infinity being one of them.
For sure.